Hello everyone, here is another video. Today we're going to be going over lesson 18, velocity. So just like always, make sure you have that notebook open and you're logged into Code Studio or Game Lab. Let's go ahead and get started. Lesson 18. Essential question: how can programming languages hide complicated patterns so that it is easier to program? Learning objectives. Use the velocity and rotation speed blocks to create and change sprite movements. Describe the advantages of simplifying code by using higher level blocks. In today's lesson, you're going to go through bubbles 1 through 10. And then for bubble 9, or level 9, I call them bubbles. For bubble 9, you'll complete both activities. Oh, my voice sounds a little funky. Okay. Bubble 10 will be graded for my class. And bubble 11 is an optional challenge, but I do recommend trying activity 8. It looks fun. And here's some notes to check out. Here are some reminders on slide 38. Some reminders of what we're going to be going through. But for now, let's go ahead and get started. Lesson 18, we're going to get started with bubble 2. Okay, so velocity X. One way to move sprites in Game Lab is with the counter pattern. For example, sprite.x gets sprite.x plus 1, moves a sprite by 1 pixel each frame of the draw loop. The pattern is so common that the sprites have a velocity X property that does this for you. Do this. Drag a sprite.velocityX block directly below where your sprite is created. Write the name of your sprite in the block. Assign the velocity X property a value of 1. Run the code. What happens? All right, let's go ahead and try it out. In your sprites drawer, you're going to see a sprite.velocityX block. Go ahead and grab that and drop it underneath line 2. Don't forget to change the name of your block right here. That should say fish because we're talking about the fish sprite or the fish variable. And we're setting the velocity to a value of 1, positive 1. Okay, go ahead and run your program and let's see what happens. Actually, let me show you what it looks like before I do that. Nothing's happening, static fish. Okay, now let's add the block again. You don't have to delete it, but I'm just showing you. Fish.velocityX gets 1. All right, here you go. Now the fish is moving to the right. So by using the X, by changing the X velocity, the velocity X, and setting it to a positive value, we made the fish move to the right. What kind of value do you think will make the fish move to the left? Negative. Hopefully you said negative, right? If we were to do -1, you don't have to do this. I'm just showing you. -1, the fish is going to go backwards to the left. And there it goes. All right, so velocity X controls left and right position, or left and right movement, I should say, not position, movement. All right, go ahead and click finish. Continuing on, excuse me. Bubble 3 is a video. Like always, please pause my video, watch the video on Code in Game Lab, and then continue. All right, continuing on to bubble 4. Moving down, here's a feather sprite that should be floating down the screen. If velocity X makes a sprite move to the right, can you find the block that will make the feather move down? Do this. Find the block that will make the feather sprite go down the screen and use it outside the draw loop. All right. Which of these blocks is going to make the feather move down? Hopefully you said velocity Y. Let's go ahead and grab that. Drop it underneath line 2. Like always, don't forget to change the name. This time, the variable name is feather. And go ahead and give it a value. Go ahead and give it a value. I'm going to choose positive 2. Run your program again, and there goes the feather. You can make it a decimal, 0.5. Let's see what happens. It's going downwards. It's still a positive value, but it's going much slower because it's only increasing by 0.5 each time. Now to make it go up, what kind of value should we use if we want to make it go up? Negative. So if I try -1, my feather should go upwards. Yep. But for this one, we want it to go down, so make sure that you keep it positive. There it goes. Whee! All right, go ahead and click finish. Continuing on to bubble 5 or level 5. Rotation speed. So far we've looked at how to move our sprite left, right, and how to move it up, down. So now we're going to look at how to rotate or how to turn. You can use rotation speed to make your sprite spin. If you want your sun to rotate by 2 degrees each time it's drawn, you can use sun.rotation gets speed 2, or sun.rotation gets 2 before the draw loop after you create your sprite. Do this. Make your sun rotate by 3 degrees each time using the rotation speed block. All right, pretty straightforward. Go ahead and use that rotation speed block. We're going to place it underneath line 2 outside of the draw loop. Don't forget to change the name, sun, and set the speed to 3, positive 3. And go ahead and run the program. And there it goes. It's rotating clockwise to the right. Now, what kind of value, same question like I've been asking, what kind of value is going to make the sun rotate counterclockwise? If you want the sun to rotate counterclockwise to the left, what kind of value should you use? Negative. Yeah, so if we were to change this to a negative 3, then the sun is going to rotate to the left, opposite direction. Right? So either one, whatever direction you want your sun to rotate, I'm going to keep it at 3 for now. So it rotates to the right, clockwise. All right, go ahead and click finish. Continuing on to bubble 6. Controlling speed. You used rotation speed outside the draw loop to make your sprite rotate when your program started. You can also use rotation speed inside the draw loop to change the speed of the sprite during the game. For example, a sprite can start rotating when the user presses the space bar, and it will keep rotating until it's told to stop. Do this, look at the if statement inside the draw loop that checks whether the space bar has been pressed. Use the rotation speed block to make the color wheel start spinning when the user presses the space bar. All right, so let's check out what we have. We have our color wheel here and the if statement right here. If key went down space. If key went down space. Now, in the previous lessons, we've used the block key down. This lesson, we're using key went down. There's a slight difference. Key down means that you're holding down the key. So if you're holding down the space bar, then it's going to have a response. And as soon as you let go of the space bar, it's going to stop. However, key went down is only looking for if you clicked the spacebar once. If you click it once and you let go, it's just going to continue going. And that's why we're using this, because we just want to kind of like activate the response by pressing the spacebar. So if key went down, we want to rotate the wheel. So let's go ahead and grab the sprite.rotation speed, sprite.rotation speed. Change the name, wheel, and go ahead and give it a value. If you want to go clockwise, use positive. If you want to go counterclockwise, use negative. I'm going to go with positive 3. Nothing's happening because I haven't pressed the space bar, but as soon as I press the space bar, then my wheel should start turning. All right, I'm going to press the space bar, and I just clicked on the space bar. I'm not holding it down, I just clicked on the space bar. And there you go. If you want it to go the opposite direction, you can add a negative, pressing the space bar. If you want it to go faster, right, you can make it go faster. It goes pretty fast, pretty quickly. Space bar. There you go. All right. I'm going to bring the speed back down to positive 2, but you can choose what speed you would like. Pressing the spacebar, just clicking on the spacebar, click, and it's continuing on its own. All right, let's go ahead and continue on to bubble 7 now. Changing velocity with position. One advantage to using velocity blocks inside conditionals or if blocks is that your sprite keeps moving even after the condition stops being true. For example, you only had to press a key once to start the color wheel spinning, and it kept spinning forever. The code below uses if statements to make a fish sprite move in different directions. Do this. Look at if statements that check the sprite's position and set its velocity with your class, with the teacher, with yourself. Discuss what you think the code will do and write your answer in the box below. Once you have submitted your answer, run the code. Okay, let's check out the if statements here. If fish.x, if the x position of the fish is less than 0, that's all the way over here, right? X position, look at the x coordinate, 15, 13, 12, 11, 10, and 8, 7, 6, 5, 4, 3, 2, 1, 0. Once it's past this point, less than 0, then it's going to set an animation. It's going to change the picture of the fish. And it's going to set the velocity of x to positive 2. So if it's setting a velocity x to positive 2, what direction should the fish be moving? To the right, right? Positive 2 to the right. Then, if the fish.x is greater than 400, if the x position of your fish, x position over here, 400 almost, right there at the very end, that's 400. If it goes past this point, if it goes greater than that, then it changes the animation and it sets the fish velocity x to -2. In this case, what direction is -2? What direction will the fish be moving if we set the velocity x to -2? To the left, right? So we should see a fish that's going back and forth and back and forth. All right, go ahead and enter your prediction. I mean, we kind of already discussed through it, but enter your prediction, click run. There goes the fish. It's approaching 400. Bam. Now it changes the animation so it looks like it turned around. And it's going left, right, minus, minus, minus. Then it hits 0 or goes a little bit past 0. Then it turns around and it's positive velocity, so it's going to the right. And it just repeats that back and forth. Every time this condition is met, it's going to do what's inside the if statement. And that's how we get it to go back and forth forever, like it's in a fish tank, which is a little bit sad, but okay, I'm sorry. So yeah, we get this fish going back and forth. Keep this idea in mind because it will be useful when we move into one of the later activities, and some of the later activities. Go ahead and click finish. Continue on to bubble 8. Back and forth. This ball bounces back when it hits the bottom of the screen. Can you make it bounce back when it hits the top of the screen? Do this. Run the code and see how it works. Look at how conditionals and velocity are used to make the ball bounce at the bottom of the screen. Add code to make the ball bounce at the top of the screen. Okay, let's run the code. Let's see what's going on. We have the ball. Boom, it hits the bottom of the screen and then goes back. But then it just keeps going forever. So we need to add the code to make it go back down. But let's see how the first part is working. Here we go. Do it. All right. If ball.y, if the y position of the ball is greater than 380, then set the velocity y to -5. So what's happening is 380. Let's see, pay attention to the coordinates down here, specifically the y coordinate. 380, I'm going down, 360, 370, 378, 980. Okay. Once the center of your sprite gets past this point, once that's going to be anything greater than 380, right? That's what the computer's looking for. If the y position is greater than 380, then it changes the velocity and it makes it negative, which is going to cause it to go upwards. So we want to do something similar, but a different position. So when the ball hits from the very top, when it gets close to the top, we want it to go down. Remember that the limits of our grid are 400, right? 400 on the bottom, 0 at the top, 0 on the left side, 400 on the right. So if we're focusing on the x and y direction, the y direction, 380, that's 20 away from the bottom. 380 is 20 away from the bottom, right? 380. So if we want to go 20 away from the top, that's just going to put us at 20 because the top is at 0. So once the ball gets past 20, meaning once the ball's y position is less than 20, right? Anything up here is less than 20. 19, 18, 17, 16, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, right? Anything less than 20, then the ball should go down.